Hi, welcome back to Strategies with Success with Professor Solis. So we're going to look at polynomial functions and inequalities. So today we're working with polynomials. Remember, polynomials have high powers. So why does this matter? Well, polynomials appear throughout algebra and help model many real-world relationships, situations. So if we recall, polynomial functions or a polynomial would look like x squared minus 4 greater than 0. So our directions would be, how do we solve this polynomial with an inequality? Recall, inequalities mean we have less than, greater than. Any one of these four symbols could be in our problem. So we just have a greater than symbol. Well, remember when you see a squared, we have 5 ways to solve that x. You learned that back in working with quadratics. So remember, we can factor, we can use the square root property, we can use completing the square, quadratic formula, or u substitution. But when you have an x squared and a leading coefficient of 1, the easiest is to factor. So we're going to do that first. So remember, factor, you separate the x squared into 2 equal pieces, separate the negative 4 into 2 equal pieces. 2 and 2 will give me a positive 4, so one of them needs to be a negative. Now, when you factor, you put each one in a parenthesis, an x in each one. It doesn't matter if the negative 2 comes first or the positive 2. And then we have our greater than symbol. We bring down like an equal sign. So what we do is we take each of our factors, these parentheses, we said each factor greater than 0, x plus 2, and you solve for x. So if we move that 2 over, that negative 2, it becomes a positive 2. We get x greater than 2. If we move a positive 2 over, it becomes a negative 2. Treat the inequality symbol like an equal sign. So we have x, oops, I put greater than, I put equal. So we have x greater than 2 and x greater than negative 2. So then we test intervals. Well, how do we test intervals? You draw a number line, mark your 0, and I'm going to mark a positive 2 right here. Negative 2 would be here, and we have to test in between the intervals. So how do you test? You pick a number. Pick a number in between that comes before negative 2. I'll say negative 3. A number between negative and 2. 0 is always good to use. That's easy to plug in. And a number after 2 is 3. So we take each one of those test points and we plug them into our original inequality or polynomial function. So basically, we're solving this problem 3 times. X squared minus 4 greater than 0. X squared minus 4 greater than 0. X squared minus 4 greater than 0. And we plug in a negative 3 squared minus 4. That's 9 minus 4. That'd be 5 greater than 0. That's true. Then we put a 0 for testing this interval between here and here. 0 minus 4. Well, negative 4 is not greater than 0, so that's a no. Then we test it with x squared minus 4 greater than 0. Plug in a positive 3. 3 squared is 9. 9 minus 4 is 5. So 5 is greater than 0. So what that means is any number prior to negative 2 works in this interval, and any number greater than 2 works in this interval, but nothing in between negative 2 and 2 work because we get a negative 4 great, and that's not true. So now, if you remember these 4 symbols, we use parentheses with the less than, greater than. We use brackets with less than, with the equal bar. So that means when I finish my number line, this is a parenthesis because of this symbol, and the parenthesis goes in the direction of the shading. So we want to write our final answer in interval notation. So if you recall, interval notation is pulling it off the graph. So that means we're going to have negative infinity, and it's going to stop at negative 2 with a parenthesis. Then we use the union symbol or. It picks back up at 2, and heads out to positive infinity. So this would be our solution to x squared minus 4 greater than 0. So let's take a step back. This is looking at polynomial functions and inequalities. When solving polynomial inequalities, you first find the zeros and you test the intervals. So that's what we did. And in closing, we want to understand polynomials and their signs. That helps us solve many algebra problems. Okay, well there we are for polynomial functions and inequalities. See you soon.